Okay, so now let's look at methods for finding limits. All right, so we've already done one method, and that is numerically. And numerically, I mean, the essence of numerically finding a limit is, well, we put in 2, we couldn't find it, so we just started putting in values getting closer and closer to 2, and we just made an observation. And while we will learn other techniques, this one, it actually works, and sometimes it is your best choice. And today with a calculator, because you can kind of speed these processes up, sometimes it is the best choice. Because we were able to observe that it was approaching 1, so we could figure out what the limit was. So that's the first technique. Number 2 is graphically. And these are in some ways kind of the same. The thing about graphically is either you have a graph, which in a lot of the problems you will be given a graph, which is fine. But when you think numerically doing this, I mean, if you put an equation into a calculator and you graph it, if I already graphed this one right now, let me turn it on. So there's my y and I graph it. Okay, so there's my graph of my equation, and really all we're doing is, this graph is just plotting points in there. But in this case, they're not talking about using your calculator per se. We're talking about you're given a graph, and so you have to evaluate that graph. So let's look at an example. So here is some function, f of x, and this is just a made-up function. But it helps us study limits. 1, 2, 3. So this graph is going to have a circle there, going out, dot there. Alright, so here is our function, and we're going to answer a couple of questions based off of this function. So let's look at A. So first of all, what is this function evaluated at 2? Now, notice when we look at our graph, down here there is a circle, so that means, well, we're kind of bypassing that 2, we're just jumping right over it. But up here is a dot. So what this graph is telling us is at x equals 2, the function is 2. Now for part B, what is the limit as x approaches 2 of f of x? Now this is a little different, because what's happening is from the right, or the left and the right, we're going to start approaching x equals 2 in our graphs. And we're going to notice that as we approach and we get closer and closer and closer to 2, we seem to be getting to the value of 0, sorry, the value of 0. Okay. So here's a good demonstration graphically of what's going on with a limit. And again, it doesn't matter what's happening at x equals 2, even though that at x equals 2 we're way up here. All that matters is what's happening as these two are approaching 2. How about C? What is f of 0? F of 0, well, here's where the dot is. So it is also 2. But then we have the situation of what is the limit as x approaches 0 of f of x. What does that equal? Now in this case, notice that as I'm coming from the left, I'm going down to 0. As I'm coming from the right, I'm going up to 2. Now one thing about a limit is, as I'm coming from the left and I'm coming from the right, you have to go to the exact same number. See, back on this example here, as I was coming from the left and right, I went to the exact same number, 1. Here, we're going to different numbers. So because we're going to different numbers, this limit does not exist. And we'll actually put does not exist. Okay. So here's a good example of the concept of a limit again. And you will be given a couple of graphs in the homework, and sometimes even on the AP exam they throw in a graph like this. And they're just asking you, if you're asked what is the limit as x approaches 0, do you understand that? Because it's not going to the same value, it does not exist. Okay, let's try one more example. And let's look at f of x equals 1 over x. And we know what this looks like from our parent functions. Now let's look at what is the limit as x approaches 0 of 1 over x. Alright, so again, here's 0. This x equals 0 is the y-axis. And as we're approaching from the right, we keep on going to basically positive infinity. As we approach from the left, we are going to negative infinity. So because we're going in, basically, we're not going to one value, this limit does not exist. Now once in a while you're going to be asked, well, explain why it does not exist. So a good way to put it that sounds fancy is you can say the limit does not exist because the limit increases and decreases without bound as x approaches 0. Alright, so there's a fancy way to write out, basically this is going up and this is going down, so the limit doesn't exist. So you're increasing and decreasing without bound. Okay, so there we go. Here is our introduction to a limit. And again, we're at this part right here. We're developing limits so then now we can later develop calculus. And essentially a limit is what's happening to our graph around an x value, not at the x value. And the first two ways we've learned to evaluate a limit, which are valid, is numerically and graphically.